My name is Julie. I work at GitHub, and I'm also the creator and organizer of passion projects. I'm really excited. I'm really excited to have all of you guys here, and I'm incredibly proud to introduce Heather Arthur, who is our speaker for tonight. So if we can just give her a nice round of applause and welcome her to the stage, that would be great.
All right, so just to give you a little background, I'm Heather, and Hearthvader on Twitter, Hearthar on GitHub, and I'm a developer at Mozilla. I work on Firefox, so that means I write open source code all day, every day, which is really awesome. In particular, what I work on is the Firefox developer tools. So these are the tools that are built into the browser that help web developers debug and create their web pages. So this is just a screenshot of the stuff that I work on. But I'm not going to talk about that today. I'm going to talk about something else that I'm really interested in, which is machine learning, and more particularly bringing machine learning to JavaScript. So let's talk about machine learning for a second. So I think machine learning as a phrase sounds really intense. Like it kind of sounds like a robot apocalypse, to be honest. And I know I remember telling one of my friends that I was doing machine learning stuff, and they sounded like terrified when I mentioned it, and they were like, "Oh my gosh, are you like making Cylons or something?" So I think when a lot of people hear machine learning, they think of like robots and math formulas, and it's a little bit like that, but it's not all like that. You're not always making robots, and it's also can be really useful even just for everyday applications. I like to think of machine learning as a collection of algorithms. And these algorithms are used to solve problems that people have been really good at solving, but programs have been pretty crap at automating in the past. So examples of this are spam filtering. So your email deciding whether or not something's spam, so you don't have to see it or not. Face detection, recommendations like Netflix and Amazon do. Character recognition, so digitizing books. So those are just some of the applications. And if you sat down to write a program to solve any of these, like let's say spam filtering, if you sat down to try to solve that without machine learning, what you might do is you might look at some emails. You might be like, all right, well, a lot of these spam emails are in all caps, and I don't see any legit emails in all caps. So you might make a rule that's like, well, if the email is in all uppercase, then it's spam. And then you might look at some more emails, and you might be like, all right, well, a lot of these spam emails are also mentioning like free iPads, and that's kind of sketchy, and my other emails don't mention that. So you might make another rule that says like, or if there are the words free iPad in it, then it's also spam. So what you're going to end up with is a bunch of painstakingly hand-picked if statements, basically. And even then, like, you can't look at all the emails in the universe. You're going to miss a lot of things just doing this manually. And what machine learning algorithms do is they find these if statements for you, and they do this better than you can and with less error. So essentially, machine learning algorithms are like better programmers than you, just for these particular applications. But so to sum it up, on the one hand, we have traditional programming, where you choose the conditionals and all the parameters. And then on the other hand, we have machine learning algorithms, where the rules are learned from the data. And so this is actually really powerful. And there are some applications, in fact, where a machine learning solution is like the only really manageable solution to that problem. So basically machine learning, super important and super useful. So now let's talk about JavaScript for a second. So JavaScript is a ubiquitous programming language. This is a screenshot of the top languages on GitHub. I believe this is like the percent of repositories where the main language is JavaScript. And some repositories are multiple languages, but I think it's safe to say JavaScript is squarely in first place. And not only that, but JavaScript is essentially the only language that runs in the browser, and also runs in server with Node.js. So yeah, it's a huge language. So it makes sense that we see if we can like put the two together, machine learning, JavaScript. So let's do exactly that. So what we're going to do is we're going to solve a problem with machine learning in JavaScript. So this particular problem we're going to solve is like you get bombarded with a lot of content today on the internet, and sometimes you're like wondering if you should bother like checking something out. I have this problem a lot. So you might ask yourself, like, should I bother like clicking on this link? Should I bother checking this thing out? So the answer to that question lies in another question, which is, does it have any cat pictures? Of course. So this problem is called cat detection. And this is actually, this is not an original problem at all. Like if you look this up, if you search for this, there are research papers and PhD theses on this going back years. So it's clearly an interesting problem. So the exact problem we're going to solve is, given an image, does it contain a cat? We're going to break it down a little bit more, something more manageable. So just given a section of image, we're going to see, is that section a cat head or not? So what we need to do this, we need something that will take an image and it'll be like, yes, this is a cat, or no, it's not a cat. So what we need is a classifier. So a classifier does exactly that. It takes a piece of data and it tells you which class it's in. For our case, we have two classes, cat and not cat. And classifying algorithms are usually trained on data where you actually already know the class to it. And some examples of classifiers, there's Bayesian classifier used for spam, k-nearest neighbors, neural networks, support vector machines. These are all different classification algorithms used for different things. We're going to use the support vector machines. So to talk about the support vector machine algorithm, so there's also another phrase that sounds pretty intense, but we'll get to at least figure out the vector part in a second. So these support machines, just like I mentioned before, are trained on data where you already know the answer. So it's trained on labeled data. And what I mean by data is basically a bunch of vectors of numbers, or arrays of numbers. And then what I mean by labels is we're going to give it a 1 or a -1. So in our case, we want to label a vector with a 1 if it's a cat and a -1 if it's not a cat. And also in our case, what we have to do, we have our labels. We know if it's 1 if it's a cat, it's -1 it's not. But what is our data going to look like? So we know it has to be an array of numbers. So we have to figure out how to take an image and get an array of numbers that represents it. So what's our input going to be? So one thing we could do is just straight up take the pixels from the image. So we could just take the RGB values and flatten it out into an array, or we could just take the grayscale intensities of each pixel. In both those cases, we're going to end up with like a ton of information. Not all of it's relevant. There's going to be a lot of noise. So we want to help out the classifier a bit. We want to give it something it can chew on a bit more easily. So here's another idea, which is we could just look at the edges in the image. So this is the edge of an image. Edges in images are places where the image changes from dark to light, or vice versa. And here we've taken the gradient of each of the images above. So each of these images on the bottom are the gradient of the image above it. So the gradient is basically like getting the edges from the image. And you see, after we've done this, we've taken out a lot of information, like the colors, and whether it's dark or light, and we've retained, basically the only thing we've retained is the shape of the cat head. So that's really awesome. That's exactly what we want, and we don't have a lot of extra information that we don't need. So that's great. So we're going to do something similar, but a little bit more sophisticated. So what we're going to do is get the histogram of oriented gradients of the image. Another intense sounding word. So it's also, I call it a Hog Descriptor. I've never heard it said out loud. I've only read it on the internet and in papers, so I hope that's how you really say it if you're a real machine learning person. But I call it Hog Descriptor. And this will like capture the edges that we were looking for before, but also capture the direction of the edges. So we'll capture like the angle of the cat ear. So, and it does it even better. And a Hog descriptor is an array of numbers. So this is perfect. This is exactly what we need to feed into our classifier. So just giving you an idea, the Hog descriptor is going to be an array of about 1,000 numbers. All right, so now we have this. We know what data we're going to give the classifier. So now we actually have to collect it. So this is an important step, getting a lot of data to train our classifier with. So what we need to do is we need to get a bunch of cat pictures and a bunch of non-cat pictures. And we want like a lot of both of them so the classifier knows about both classes. So for the negatives, those are the images without cats. For those, we're just going to like download a bunch of images from Flickr and crop out random sections of them. And then for the positives, we need thousands of cat pictures. And we also just need the cat head too. We need to crop around the cat head. So there happens to be this amazing data set of cat pictures. Each one is annotated with the location of the ears and the eyes and the nose. So this is very, very convenient. I can't believe this exists, but it does. So that's very nice for us. So all we have to do now is take each of one of these cat pictures, rotate it so that the eyes are level, and then we crop the picture so that we're just framing the cat's head, like that. And then also, we want each of these pictures to be the same size, so we can feed it into our classifier. OK, so that's awesome. So now we have like thousands of cats and non-cats, and now we can start training with that stuff. So training, this is where JavaScript comes in. So I'm just going to go through this a bit. So first of all, there are a couple of packages that we're using from the npm package manager. There is a Hog Descriptor package to do the Hog Descriptor, and then svm package, which will give us our support vector machine. So we create a new support vector machine, and then we go through each of these pictures that we have, and then we first extract the Hog Descriptor from it, and then we give it a label, one if it's a cat, and negative one if it's not. And then finally, once we've gotten all these inputs and their respective labels, we can call svm.train with these inputs and labels. All right, so that's it. So we've trained our support vector machine. And just to give you a better idea of what's happening when you do that, what training does is it creates this state. So this is a JSON object that is the train state of our support vector machine. Maybe you can see, yeah. So you know how I said earlier that machine learning algorithms find if statements for you? So they actually, that's actually not what's happening. In reality, this algorithm is finding floating point values for you. So the if statements are fixed, and the floating point value is changed based on which data you train it with. So the values of these numbers here will determine, will be like combined with your new data that you haven't seen before, and will help the support vector machine determine which class it's in. Let's give you an idea there. So OK, so we've got our support vector machine trained. So now what we have to do is like go back and start solving our problem, which is the first problem we're trying to solve is just given a section of image, is it a cat head? So what we're going to do, all we have to do here is take this image that we're trying to classify. We extract the Hog descriptor from it, just like we did with the training image. And then we just call svm.predict with that descriptor. And that result will be a 1 or a negative 1. That's not a label. That's actually just a prediction of what the support vector machine thinks the image is. So then if it's 1, we'll say true, it is a cat. And if it's not, false, it's not a cat. OK, so great. We've got this function that will take a section and tell us if it's a cat head or not. So now we can go one level up and finally answer our original question, which is, given an image, does it contain a cat? So what we do is we take this function that will classify individual sections, and we run it on all the sections in the image. So we're testing windows at all different locations and scales throughout the image. And then after that, around cat heads, we'll have a bunch of overlapping detections. So we're going to combine all those. And also weed out, in the process of doing that, we're going to weed out any detections that, that don't have enough detections. They're probably false positives, so not really cats. So yeah, and then that's it. That will answer our original question. So let's go to a demo. Okay, so we have Kitty Dar, which is, I actually did this about a year ago, but this will run this algorithm that we just made. So we're going to try it out. So we're going to give it a cat picture. OK. And you see what it did was it did that thing where it detected at different windows, and then it combined those overlaps. So bam, there's a cat. We're going to try another one. Yay. OK, and we're trying another one. You'll see the limitations of it. All right, so you can see here that it got 2 cats, but there are 4 cats there. It didn't get the 2 on the sides. It didn't get the one on the left. Yeah, it's left for you. OK, it didn't get on the left because we didn't train the classifier to detect cats that are facing the other way. We just trained it on cats that are facing the camera directly. And then the one on the right has an abnormal shape. So it's not, and it's also a little tilted, which will make it harder as well. So yeah, but still, it works pretty well. So that's pretty cool. And I have to mention one other thing that I did. This is running a web page, but we have to run it on a web worker, so on a separate process. This stuff we're doing is serious number crunching. It's basically the equivalent of doing a while true loop for a few seconds in your page. So you really want to make sure you're not running that on the main thread, because it will block everything and it will be really bad. So that's one other thing that I did as well. All right, so what I think is really awesome about this is running in the browser. I just think that's the coolest thing ever. It's all running on the client side, and actually, well, you see the URL, harthur.github.com, so you know it's static, and yeah, it's really cool. So finally, yeah, okay. All right, so we just saw that running in JavaScript. So a few years ago, or several years ago, this just would not have been possible in JavaScript. And there are a few things that have made it possible. So I guess the big one is just speed. JavaScript has gotten a lot faster over the past few years. And this kind of number crunching just ran way too slowly in the past. So that's one thing. Another big thing is Node.js, which came out a few years ago. You wouldn't have been able to do that collection and training stuff we just did without Node.js. You really need a command line and access to the file system to do those things. But I have to note that you don't have to do each of these steps in the same language. So you could do your collection or training in another language and then export your trained state to JSON or something and then use it from JavaScript too. So that's another option. And actually for the collection, I think I used a Ruby script to get Flickr images because the API was easier to use there. So yeah, so you could still mix it up. But Node.js makes it possible to do these steps in JavaScript if you want to. Another thing that's helped out a bit is typed arrays. So in JavaScript, usually when you have an array, you can put anything you want into it. You can mix types. You can have indices where you don't put anything in it. And then some have strings, and some you put numbers in, and some random objects. So it's very lax. And with typed arrays, you're telling JavaScript, this array will only contain, floating point 64-bit numbers. And so what JavaScript can do is, it can figure out the offset into memory a lot faster using that information because it knows the type of everything in the array. So it makes it a lot faster. And in fact, it makes it about 2 times faster for training. So instead of it taking like 10 hours to train our support vector machine, it takes like 5 hours, which is a big deal if you are trying to iterate and figure stuff out. So that's one thing. Another thing is that workers really make this possible to run this stuff in the browser. Otherwise, there's no way you'd want to run it in the browser. It would just block everything. So there's some big things that helped out a lot. And as you can see, it's like clearly possible to do it now. But there's still stuff that JavaScript is lacking. JavaScript is definitely not your typical language you use to do machine learning. Things like Python, languages like Python have a ton of really good building block libraries, and like MATLAB and stuff like that. And which just JavaScript is lacking. Like matrix math library, statistics, image processing, that kind of stuff is just not quite there yet in JavaScript. So that's one thing that still really needs to happen. But also, it would be nice if it were even faster, so that's cool. But yeah, let's see here. But things are still happening though. There's some libraries out there. There's neural networks, the support vector machines, clustering, and the natural language processing library, which I really like, called Natural Node. That also has a Bayesian classifier, as well as doing natural language processing, which is kind of similar to machine learning in some cases. So I wrote the neural networks and the clustering a few years ago, but also Andrei Karpathy has been contributing a lot of libraries too, including the support vector machine implementation, which we just used. So that's cool. And there's some applications in JavaScript too, using machine learning. My favorite one is this real-time face detection. So this is face detection that runs really quickly. So that means that you can do it on every frame of a video, like an HTML5 video. So that is super cool. There's also a hand and eye detection library. And the first machine learning I heard of in JavaScript was this OCR CAPTCHA solving algorithm, which is pretty cool. And that uses neural networks to crack CAPTCHAs. Yeah, so it'll be really interesting to see where machine learning will go in JavaScript. It's hard to tell right now, but I hope that people will try it out. Sure. And finally, I want to talk about if you guys are interested in machine learning. So machine learning doesn't always look like this. There's not always this classification. You're not always doing classification. Sometimes you're predicting continuous value like temperature or stock price. Sometimes you don't have to do this training step at all. Sometimes you're not using labeled data. So there's a huge variety of things that machine learning does. So just be aware of that too. This is just kind of like a small example. And also, there's a free online Stanford machine learning class. And that's actually starting April 22nd, so that's in a few weeks. And that's hosted on Coursera. I actually took it a year ago, and it was really good, and it really helped fill in a lot of holes for me. So definitely check it out. And finally, what really I think I learned the most from is just starting with a problem and going from there. So when I was working on Kittydar, I just the first thing I just searched for cat detection, and then from there, found research papers, I read them. When I didn't understand something, I looked it up on Wikipedia, and then they linked to other papers and read those. And I actually ended up learning like a ton of stuff just from doing that. Like so much stuff I never thought I would know anything about. So there's a lot of value in that. I'd really encourage you to, if you're facing a problem you think you can use machine learning on, just like go for it, and you'll end up learning a lot. I think that like our brains are kind of like these machine learning algorithms where you can just kind of like throw fancy words and research papers at it, and eventually it will just like figure things out. That's what I found, at least. So yeah, anyways, so try it out. It's my best suggestion. Okay, thanks.
Welcome back. I hope you're enjoying all of the yummy snacks that my wonderful coworkers provided for us. Pretty awesome. That was not a plug, I swear. So Heather just gave an amazing talk, and it was like probably a lot different than Rachel's talk last week, which was more sort of like high level and organizational, whereas Heather's was like super like technical. And so I'm just kind of gonna jump in and ask you the question: how did you get into programming?
No, it got turned off.
There you go.
Okay. So yeah, I got into programming in high school. There was this like 3-week seminar period class in high school where we could take like one of like 5 classes or something, and my friend Alyssa and I decided to take this game programming class, and it was just kind of random. We were just like, oh, games, like that sounds kind of cool. And so we signed up for it, and just like the first day of class, you know, I saw what the code looked like, and I saw what it involved finally for the first time. Like I had no idea what it like entailed. And
it was exactly like the movie Hackers, right?
Yeah, stuff streaming down your screen. Yeah. No, but I just like I saw the code, and I was like, yeah, this is definitely what I want to do. This is awesome. And then ever since then, I just, you know, yeah, I basically got started in school, and I kept on taking classes, and then majored in it in college, and then so I went from there. Yeah.
That's really awesome. You have a really awesome story in that it's completely different from Rachel's, who learned to program kind of like after college. You went to school for a CS degree at Carnegie Mellon, and you continued straight out of college. But I think it's really interesting, kind of the way that you found Mozilla. Did you kind of want to like talk about that, or?
Yeah, so I work at Mozilla now, and I've worked there ever since college. And actually, I found it, like I was at my career fair at school, and I'd known that Mozilla, I mean, I'd used Firefox for years. I knew about Mozilla, but I didn't know that they actually hired people. So when I saw their booth at my college's career fair, I was like, oh my gosh, they like, you know, I went and talked to them, and I probably, I don't know, I think I sounded totally like a total idiot, but I guess they liked me all right. And then I became an intern there. So I interned there one summer, and then when I graduated, I started working there because I loved it so much. So.
And you've been there ever since?
Yeah, I've been there ever since, yeah.
What's it like to work at an open source company?
It's awesome. I don't have anything to compare it to, but it's really awesome. I don't think I could go back to proprietary unless like I had to. It's really cool to be able to talk about what you're working on and like not have to think like, oh, maybe I can't talk about that or something. And I can release, yeah, everybody can see my code. You get, the best part is like getting the contributors too. Like you'll be like working really hard with your team, and like there's these bugs that are like falling by the wayside, nobody's fixing them, and then like a contributor will come along and fix this like really critical paper cut bug, and it's just like the most awesome thing.
Yeah, it's pretty awesome. So GitHub, obviously, like a lot of open source projects, and I got the privilege of talking to Heather before her talk, so I cheated a little bit, and like I got to hear her story a little bit, and like how she got into programming, obviously, and also open source. But we talked a little bit about like sort of the role that like GitHub plays in open source, and like what it was like to sort of transition into like using a tool like GitHub.
Yeah, yeah, it was awesome. I've been doing open source for a few years now, and I've been doing it before GitHub was around. And I was hosting my code on like Google Code and stuff like that. I definitely wasn't getting any contributions. I don't know if people saw it even, but definitely after GitHub, when I started putting my stuff on GitHub, it's like, you know, I got so many like pull requests and issues, and like people saw my code, and it's just like
the best great. Christmas presents, basically. I think pull requests make the best Christmas presents.
Yeah,
so
definitely. Yeah, so yeah, GitHub has been awesome, and also Git too. It's helped. Yeah, so that, yeah, absolutely, very like essential. So.
If anyone has, I kind of plan to like make this more into like a discussion. So if anyone has any questions, throw your hands up. Like, don't be shy. Oh, there's the question. Hi, Steven.
Did you study mathematics and statistics as part of like your college track, or is that something that you started learning afterwards in order to use that to solve problems?
So I did, well, I was a computer science major and I was a math minor, but like the math I was doing was like this crazy stuff, like ring theory and stuff. So it wasn't really like very practical. Like for instance, we had the option to take a matrix algebra class or a linear algebra. Linear was like really theoretical. And I really could have used this matrix stuff for like the stuff I was doing here on the talk, but like I didn't take that class. I took the really theoretical linear algebra class that like was really abstract. So I really like kind of skipped over that practical math and statistics stuff actually. So I really learned that like through this. Another thing that I learned, like, I don't know if you guys like found this yourselves, but when I was in school, like taking trigonometry classes, I was like, trigonometry was like the subject where I was like, okay, this is like, I'm never gonna use this, you know, just like these sine angles and stuff. But for like doing the cat detection, like I had to figure out how to rotate the image the right way. And I was like, wow, like I'm actually using this stuff. And I had to like really relearn that. So yeah, basically a lot of it I just learned from like figuring out problems, yeah, sure. Even though I did take classes on related stuff, yeah.
So you studied CS in school, and I'm always really curious to hear like how you chose like a language or how you chose what you would work on next. Because you obviously like you code a lot in JavaScript, but you also write C, Me2, and HTML and CSS.
Yeah, so I guess my job has been JavaScript programming for so long. And I mean, I have to write JavaScript for my job. Firefox is written, like, the parts I work on are written in JavaScript. And sometimes I have to do platform stuff, which is C++. So, like, right now it's really about, like, what I have to use. Like, you know, I can't just call out to Ruby from Firefox or something, or people will be very mad at me. But so that's part of it. But also, I mean, I do have a lot of side projects, and they're mainly JavaScript. I really like doing them in JavaScript so that they run in the browser, because I love it when things run in the browser. So, but also, I love Node.js too a lot. It's been like made it really easy to make like command line scripts and like one-off things too.
So KittyDar wasn't your first open source project, obviously, right?
No, definitly not. That was just KittyDar is just a demo to explain machine learning. But I think the first open source I did was like working as an intern on Mozilla stuff. But I guess the first one I did myself was like a Firefox add-on that like helped web developers pick colors on their web page and save colors and tag them and stuff like that.
That was like your first experience with machine learning, basically.
Yeah. Actually, I did use that was my first experience with machine learning too, because like I had this problem where like I'd be displaying these colors like that he collected from this web page. I also display the color value on top of this color. So if it was a light color, I'd want to display black text over it. And if it was like a dark color, I'd want to display like light white text over it. And their color is like bright green, where it's like it's not really immediately clear where like which color you want to like black or white to display over it. So I looked up some formulas for doing that, and I found them to be pretty spotty. So I had the back of my head, like I had heard the words neural networks before, and I thought it sounded like super cool, because they do sound really cool. And I figured out actually like I might be able to use them for this. And so I wrote neural networks in JavaScript. It was a Firefox add-on, so it had to be JavaScript. And it actually worked pretty well at determining like which color to use, black or white, over a random color. So yeah, so that was my first foray.
Cool. And you still work on open source projects outside of what you work on at Mozilla, or does it matter?
Yeah, occasionally, like whenever I have time. At this point, I'm mainly just maintaining open source projects, which is a lot of work in itself. So I'm trying not to create too many new ones, because then I have to maintain them. But yeah, mainly work, which is also open source. So,
do we have any other questions? Yeah, the excited guy.
You mentioned Python and all those amazing ML libraries in Python. And last week we had Mozilla launching Asm.js, which would enable Python on LLVM being used on the browser. Do you think that? What do you think will be the impact of this technology? Detecting face cats and ML in general.
Yeah, I think that I don't know yet. I have no idea what effect that stuff will have and like how many people will end up using like Asm.js and other languages compiling to JavaScript. I can't. I
Predict
really
the future,
can't predict
Heather.
that.
Right
I'm
now.
not sure. It's not something I would do right now. Like I wouldn't be like, all right, I'm gonna use this Python and convert it to LLVM and have it run on Scripton or whatever. Yeah, I don't know.
The answer, yeah,
But
we don't know.
But it will be really interesting to see, and I hope people try it out for sure. Maybe I'll try it out at some point. Yeah.
So, any other questions? Yes, Taya. Oh, sorry.
I thought that was
Now fight.
Do you know if citizen science projects like Galaxy Zoo or Planet Hunters are using machine learning behind the scenes because they're collecting so much data that could be used for that via like people basically tagging different photos and things like that of space stuff?
Okay. Oh yeah. Sorry. So
It's a hard question to
Yeah.
repeat.
Was
She's
it
asking about
Galaxy?
specific projects and whether they're using machine learning.
So was it Galaxy something or?
Like
Or-
citizen science projects like Galaxy
Yes.
Zoo and Space, Planet Hunters and Galaxy Zoo, and there's a few others out there. There's like protein folding ones and all kinds of that, where they're basically collecting a whole bunch of data from like people who are entering in like information about images they're given. And you think on the back end they'd be collecting that information and then developing machine learning to do it
Yeah,
without people.
I've actually heard of at least like one app that's actually a game, and it's used to like detect like protein bindings or something. And so they're using So there's a lot of really cool things. I mean, that I think is like a native like iOS app or something like that. So it's probably running on like C or something. I don't know. But I don't know if any. Do you know of any others? That are
Yeah, I'm not sure, but yeah, most likely they are. I think anytime that you have a lot of data and you're using it to predict stuff, it's probably using machine learning.
Yeah, definitely.
But,
When we talked, we like some like really simple like examples of machine learning and like applications that we all use are sort of like. You want to talk about them a little bit? Or? I mentioned some of the talk, like spam filtering. Everybody benefits from that, and also. I think a lot of recommendation engines use some machine learning to like recommend things for you based on what people like you also use. So when Amazon tells you to buy that horse mask, they're obviously using some type of machine learning.
Yeah. And anytime there's like computer vision that like uses a lot of machine learning. So face detection, the self-driving cars are probably using it too. Yeah.
Laura, did you have a question? She's hiding. You can call people out by names.
What advice do people for people who are getting into programming?
The question was, what advice do you have to people who are getting into programming now?
I've been programming for so long that I wish I could empathize more. I think. For me, like I came from an academic background, and so I kind of, so you could always do that, which is like just taking online classes, like free online classes, like the machine learning one I was talking about. Like even that one, you don't have to know programming to take it. The professor Andrew Ng is like really good at like explaining things, and like you don't need to know programming, but you might end up learning some in the meantime. And also, I know I've heard of Codecademy, I think, that does this like online JavaScript learning, and I've heard like nothing but amazing things about that. People saying how easy it is and how easy it is to understand things immediately from that. that's another thing I've heard about. So that's kind of coming from like the schooling kind of background, but also I think like if you can think of any problem that you just want to solve, kind of like what I was talking about machine learning, like it really, once you like try to figure something out, you'll end up learning so much, and then before you know it, you'll like know a lot of programming just by like trying to solve something. So, yeah.
Any others? Oh.
How would you contrast the approach that you take when approaching a machine learning problem versus traditional programming problems? How do you make those logical leaps to find the algorithm?
So I think he's asking how would you approach machine learning problems differently than regular problems, maybe? So I guess with machine learning, well, I certainly end up doing like a lot of research. With the regular program, I'm kind of like, I know what steps I'm going to take more or less. I'm like, okay, well, I'm going to make this object, and then it'll probably do this thing, and it'll communicate this way.
Yeah, there are a lot more like conventions and like
Yeah.
best practices around regular programming problems, whereas like machine learning is still kind of very open and
Yeah.
depending on the problem, I mean, there can be an entirely different path, right? I mean,
Yeah, exactly. Yeah, I think with machine learning, it's more like you have to do a lot of research. Like, you know, you're like, how the crap do I do this? And then you end up just searching for it. And also another big thing is like you need to figure out where to get your data from, because there's always data. So that's a big difference too. Yeah.
Okay. I was wondering how you choose whether to use web workers or to use a more traditional like RPC asynchronous framework, and what are the trade-offs in your mind?
She's asking whether how do you decide between web workers and like RPC asynchronous.
Yeah, because it seems
Okay.
to me, at least naively, that they have a lot of the same benefits. That you can do data computational tasks or like computational heavy tasks without worrying about it freezing up your browser.
That's interesting. I literally haven't heard of the like RPC asynchronous stuff. I'm not sure exactly what you're talking about actually.
More just like event-driven, so like you send off an RPC call to a server. Maybe I'm just using the wrong terminology.
Oh, I see.
And then let the server handle the processing and you send it back.
Yeah, okay, so yeah, it's basically like whether like doing it in web workers in the browser versus having it done on the server and like calling out to it. Okay, cool. So yeah, there's a big difference there. So one thing, I like doing my web pages all on the client side if I can, and like having as little server side as possible. Not that I'm saying like that's the best thing to do or anything, but I usually do that, so I prefer using web workers to do something like this. And also, it's just like one less network request, which is cool, and one less dependency on that. So yeah, I mean that's the main difference, I guess. It's just whether you want to do the computation on the client or the server, and do an extra network request, probably. I guess.
we have 2 more questions. So Hannah, want to go first?
What like really drives you? Like, what are you really passionate about? What makes you get up in the morning, be excited to go to work?
So he's actually like, yeah, what makes me passionate, or
Yeah, what drives you and sort of like what makes you get up in the morning? Like, what are you excited to work on the most? Or?
So I'm really excited mainly about with my job, I'm like very invested in making the Firefox developer tools better. Like, I think it's really important that we help web developers out, and so that drives me a lot. Like, I'm like, we need to get this feature done so web developers can use it. So in that sense, like, a lot of my motivation is about like just getting stuff done, like getting particular things out there so people can use them. So that's like the main motivation. Also, just programming in general is really fun, so that's like a secondary motivation. It's just like, I'm like, oh, I get to do fun stuff now, so that's cool.
That's really awesome. One of the things, or one of the reasons we started Passion Projects originally was we wanted to hear from women who like really loved the companies they worked at. And I remember during our interview, I asked, like, what is your favorite thing about working at Mozilla? And I think you said it was the people. Do you want to talk about that? Or?
Yeah, definitely. At least, I haven't worked at other companies, but at least at Mozilla, like everybody there like really cares. I mean, it's an open source company. It's also like wholly owned by a nonprofit. And we have like a really clear like mission, and I think a lot of people that work in Mozilla are like really passionate about that. So it makes for like really awesome coworkers, and I just and they're also, you know, they're doing open source, so they're really used to helping out a lot of people, and so they've been like extremely helpful. And they're also just really nice. Like they're not assholes, basically, which is awesome. So I just love everybody that works at Mozilla. Like I've never met somebody that works at Mozilla that I didn't like a lot. So.
Awesome. And like that's another thing about when you're getting into programming, like surround yourself with people who want to help other people.
Yeah.
I know I was really lucky. I started like writing code when I was at Yammer, and I had just like this incredible network of people around me who really wanted to help me learn really quickly, and I got just pointed in the right direction. And I mean, if you're self-motivated and you have those types of people around you, it's like the perfect formula for success, business, other things. Yeah. So like people is such, and open source companies I think attract those kinds of people, like people who want to build things that make other people's workflows more efficient and make them better at what they do.
Yeah, totally. Yeah, open source companies are like the best. Yeah.
No offense, everyone else.
Yeah.
Cool. Well, thank you so much for letting us rack your brain, and also for the amazing talk on machine learning. We record all our talks, so we usually post them in the follow-up blog post. So anyone who is watching from home and maybe missed the beginning or whichever, we'll catch you up. And thank you so much, Heather, for being a part of Passion Project.
Oh, thank you for doing this. Thank you.